And again, thank you everybody to be here with us today. I am Eleonora Parisi from Cherry, and in the room with us, your trainer will be Michael Sparks from the University of Manchester, but also Michael is editor for the RSQKit, something that he will give you more details in a minute, because this event is part of a webinar series organized by the project EVERSE, where we collectively work across different scientific communities with one goal, meaning bring everybody developing and discovering quality practices for research software. And the topic of this event today is going to be about research software stories. And just to clarify how the event is going to be organized, we have a first session and a second session with 5 minutes break in between. And the first introductory sessions, Michael will bring us through like the discovery of what research software stories are in the context of the work done in EVERSE, in particular the RSQKit, why one should bother writing stories and for whom, and then we will go through a short walkthrough of the template. And then for those who want to stay for the second hour, we're going to, sorry for the typo, it's brainstorming about how we can start writing one research story and then wrapping up with some conclusion on how research stories as a concept is really relatable and useful for your daily work as a researcher, as a research software engineers. So I'm very happy to stop sharing my screen and to give the floor to Michael.
So, hello, good afternoon. Thank you for joining us today. My name is Michael Sparks, and over the next 2 hours, we're going to explore something deceptively simple. It turns out to be how it can have a surprisingly large impact on how effectively we can conduct, communicate, and sustain our research that is telling the story of our research software. So, that's the welcome. So, first of all, our agenda. So I'll come back to this, but there's 5 mini sessions today, one of which is an introduction, which is about 10 minutes. The research software stories, again, similar. These are indicative timing, so it's not going to be exactly 10 minutes, 20 minutes. So what are research stories, why write them, how we write them, template walkthrough, a short break, then a guided writing session, which is split into an actual session of writing and then also discussion and Q&A session. So, introduction and context. So, before we get into anything substantial, a few introductory notes. There's a slightly different angle on the things. Whilst it's being recording, the session is being recorded, so that participants who cannot attend live can revisit the material later. The transcription is switched on specifically to assist with a guided writing session later. You're welcome to keep cameras on, keep cameras off, whichever is most comfortable for you. I will ask you to mute your microphone unless we're in a Q&A session, but please do use the chat. If you'd like to put in where you're from and where you're coming from and what you're interested in getting from this session, that would be great. Likewise, you can pop questions in there, but I would ask you to perhaps remind me of them when we get to the any Q&A sessions, because I might miss them if they're buried in the chat. I can't see the Q&A section on here, so that's why I mentioned that's sort of slightly different from the slides. So anyway, so structure, as I said, is essentially 2 parts. The first is presentation focused, and I'll focus on the core ideas, and the second is hands-on, and you'll begin drafting an outline of research software for your own story for your own project. So who am I? Well, I'm a senior research software engineer at the University of Manchester. I'm based in physics and astronomy and work as part of the eScience Lab team on the EVERSE project. My background oops, wrong slide, is computer science, and I've been writing code for longer than I can remember. I'm a professional software engineer for over 27 years, and over 23 of those in an R&D context. So that's been from things like broadcast studio projects, network systems, through concurrency component systems, mass participatory projects, through to building the original BBC microbit prototype, which we trialed in schools to enable children to be able to learn the core of software development. So it's kind of a common theme about me liking to encourage people to do good software engineering with these things. So we mentioned EVERSE and RSQKit. So I've been with the EVERSE project and the University of Manchester since earlier this year. But what is the EVERSE project? Many of you on this call may already know this and may have attended other EVERSE seminars beforehand and have other reasons for knowing it, in which case, hello, there's lots of familiar faces, which are nice to see. However, some of you may have seen this on a LinkedIn message promoting this and thought that sounds intriguing and not know anything about EVERSE. So briefly, EVERSE's core goal is to improve the quality of research across the EU science clusters by increasing the quality of research software that underpins that research. That's kind of the core goal. The blurb would be that the EVERSE project aims to create a framework for research software and code excellence, collaboratively designed and championed by the research communities, and in pursuit of building a European network of research software quality and setting the foundations for a future virtual institute for research software excellence. So one of the works in progress for this project is called RSQKit, which is a research software quality toolkit. This captures and shares good practices in terms of metrics, such as dimensions and indicators, but also in terms of a collection of common tasks and tools and descriptions of good software practices in the community. This allows sharing of best practices, not just in theory, but also in practice. So why this matters? So let's talk about why we're doing this today and why this matters. So the claim is quite simple. If you care about reproducibility, onboarding, or being able to restart your research after a gap, then having a clear, structured understanding of your research software, something which can be grasped quickly, is one of the most practical things you can do to support yourself and your collaborators. It might sound obvious, almost trivial, but in practice, many of us never write down those clear initial speed bumps in a clear, coherent, accessible way. This also prevents a whole bunch of other things which are very useful to be able to enable, which we'll come to. So research software itself is often deeply embedded in the scientific process. It performs analyses, it transforms data, runs simulations, generates models, or glues together entire workflows. Yet despite being essential for research outputs, software practices often remain hidden, stored in the memories of a number of different people, scattered in documentation or in isolated code comments. And when that happens, the knowledge we rely upon is more fragile than we think. So one of the things that we have to consider now is consider the situations we often find ourselves in regularly. You brought on a new PhD student or MPhil student onto your project, or a postdoc, or maybe you're asking help from another engineer or another RSE team or contractors. What happens next? Almost immediately, and quite understandably, you get a bunch of understandable, very predictable, very reasonable questions. Questions like, what does the software actually do? What scientific claims depend upon it? Does cancer diagnoses depend upon it? What assumptions lie beneath the surface? Why does this software exist? Who relies on it? And what should they read or understand before they can contribute safely? So, and answering these questions takes time. So if you've ever been in the position, you know it takes time, sometimes lots of time. The answers aren't always written down anywhere. They might be scattered across old emails, issues, notes, or tribal memory within the group. And this isn't just about new team members or newcomers. These questions come up time and again when talking to colleagues in adjacent areas, at conferences, at workshops, when you're applying for funding, or when you're trying to remind yourself what you were doing 6 months ago after a period of leave, or attending to other projects. Our research can move at quite a pace, and it's very easy for that context to become separated from the code that implements it. You can also flip the perspective. I've been in this situation. You join a project, you're brought in to help. You're the collaborator, the contractor suddenly arriving because something needs your attention quickly. You're an RSE brought in, you're a scientist brought in, you're an engineer, you're a postdoc. Your context matters with this. But perhaps the software has reached a bottleneck and needs reviewing or extending it. Again, the first thing you do is ask those questions, those same foundational questions. What is it? Who depends on it? What underpins it? Without clear answers to these questions, the first days or even weeks of work may become detective work rather than productive work. And lastly, funders. This is something which is quite easy to forget because when most of us are either software engineers or researchers or similar, we're not the people who are doing the funding. But funders, this is critical information for them as well. They want to know they've got the same sorts of questions. So if you're applying for a grant that involves software or even maintenance grants for software, committees do want to know whether the software and the systems you're relying upon is credible, maintainable, and relevant. They want to understand the context. People rely on what other people use it, rely on it, or benefit from it. They want to see plausibility and purpose. And without this narrative, it becomes very difficult to it becomes harder to communicate the value of the software, why it matters, whom it serves, and how it contributes to research aims. And the simple reality of all this is that many of the conversations about research software do rely on that clear understanding that can be communicated quickly, reliably, and consistently. And without that, we often risk misunderstandings. I've often like to say there is a common misunderstanding of our work in projects and teams and organizations. And the further you get from the individual, the much more likely that misunderstanding is going to happen. Got a good idea, but it's a good misunderstanding. Because people believe that they understand it, and that's one of the issues. So this is how to make our own work easier to share and sustain. So this is where research software stories come in. A research software story is a short, structured narrative. It captures the essentials of your project, what it does, who it serves, how it's developed, how it supports your research. It's not a technical manual. It's not a full set of documentation. It's not a marketing document. More, it's a spider's web document. It's the thing that sits at the center that points you at all of these different things. It's a way of answering in one place the questions that collaborators, funders, reviewers, and newcomers always ask. The questions that sit beneath the surface of almost every project as fundamental working assumptions. So why do they help? Well, it should help. That it helps. It forces you to it encourages you to reflect on the current state of your project when you write one of these things, the assumptions that brought you there, its sustainability, its connection to research objectives. When you do this, you will look at it and go, oh, I've got huge gaps here. What have I got missing? It's connection to your research objectives. And it can reveal the gaps and strengths you hadn't noticed. And it can show you the difference between what's implicitly known within your team and what's communicated explicitly. It can guide you towards better practices without requiring you to overhaul everything all at once. So in RSQKit, we're going to talk about how research software stories are used in that context. RSQKit has started gathering examples of these, and we'll be gathering more examples of these from various different scientific domains, from physics and astronomy to life sciences, environmental modeling, digital humanities, and so on and so forth. These stories are one part of this ecosystem, and when shared, they help make things visible and what goes into developing good research software, and actually helps with cross-pollination and to help people learn from one another's experiences. In theory, they should also help with saving time. That's the purpose of it. So personally, I found that when you've got this information, not necessarily in this format, when you've got this information written down well, it can save enormous amounts of time in onboarding, explaining projects, restarting paused work, time establishing credibility in grant proposals or internal proposals inside private organizations. They can also help create more reproducible research by making those assumptions visible and surfacing any unanswered questions. So in this hour, we're covering what stories are, why they matter, how they support your work, and how having a standard RSQKit template helps structure them and make them more accessible. In the next hour, you'll start drafting them. You won't need to finish it today. The aim is simply to give you a structured space and to think through these questions and capture the essential points. Lastly, I don't think it's very easy to think of documentation as bureaucratic. I really don't think it is. I think it's a practical tool that helps you make your research easier to conduct, helps you easier to step back and think, are you covering everything you need to cover? And helps make it easier to sustain. This link on the support materials is duplicated through different parts of the presentation, and I'll also drop these in the chat as well. So just let me do that now.
I can do it if you want, Michael.
Oh, thank you. That'd be great. So let's move on in that case to the next section, which is what they actually are in practice. So I'll close that one so I don't need any. So And just open it. There we go. Notes back. So where are we? We are here in the present presentation so far. So let's move on. What are research stories? Well, they're a short, grounded explanation of this is what sorry. Now we've set the context, let's talk more about what research software stories actually are. You've got the general idea, but for the next 10 minutes, I want to give you more of a concrete, grounded sense of what these stories actually look like, how they're structured, and what the way they're structured, and what makes them useful in practice, not just in theory. And as part of this, I should just quickly bring up where they sit inside RSQKit. RSQKit has been mentioned a couple of times. RSQKit sits on the EVERSE website here. It's got a bunch of different sections. We've got things like about the different dimensions and quality. We've got tasks that somebody may wish to do. And we also have a section on research software stories. And in particular, the one which I'm going to dive into is this Baylor one. Now, these are 3 different stories that currently exist, and there's more which are in progress. But in terms of what you'll see there's a standard structure, and it covers all the high-level aspects that somebody might wish to know about a project. Now, I'm going to dive into this in detail. I just wanted to show one concretely so that somebody got an idea of seeing what it actually looks like. And what the level of depth we're talking about here is not, it doesn't have to be a huge level of depth, but it should ideally be a spider's link to lots of different links which are related. So things like the documentation, where your GitHub repositories are, and so on and so forth, and what practices you have. And the materials, as mentioned, links to this location, incidentally, which has all of the various different details which we're talking about today. Right, so let's go. And now it's back up. So what makes them useful in theory? So I briefly showed you that was Baylor's story from RSQKit. Sorry, my screen is facing itself. Right, so it should be clear from this that we're not talking about just technical documentation. Most of us, when we describe our software, instinctively jump to talking about technical documentation. So we talk about installation notes, the dependencies, the API references, maybe workflow diagrams, if we're feeling ambitious. But those things are important and they all serve a purpose, but the technical documentation is usually aimed at somebody who already knows that they want to use the software. It doesn't answer the bigger questions of why the software matters, how it fits into the research, or what questions are shaped by its development. And it certainly doesn't help somebody who needs to understand the project at conceptual level before they work with you. And these stories help fill a gap. It's a short, structured narrative, captures the key elements of the project in a way that's easy to read, easy to share, and easy to refer back to. It's kind of like a cross between an abstract, project brief, and institutional memory rolled into one in one concise document. So, but why call it a story? The term story is slightly unusual, especially when you look at it and think, well, it's a bit like a case study. But in this particular case, we're looking at it from literally, think of it more like a news story or a documentary story. It's analysis and structure and evidence. But in this case, it forms a narrative. This is what the problem is. This is what who the people are involved. This is what the solutions are. These are the tasks. And it forces us to step back and ask some fundamental questions along the lines of, what's the shape of the project? What problem is it trying to solve? Who depends upon it? And what research assumptions does it make? And how does it support that research? Now, these are all narrative questions in a scientific sense, not a fictional narrative, the explanatory narrative of a research project without jargon. And having some shared structure between these stories matters. It enables somebody to go, okay, I understand my project, but how did they do it? And they know where to jump in. And that consistent structure, which is what the RSQKit template uses, is deliberately designed to work across scientific domains. So it's not tailored specifically for climate science or biology or physics or humanities. The same questions can be asked of any project, regardless of domain or scale. It might be a massive project that's an EU project with 20 organizations, hundreds of researchers, or it might be just a single project with a simple analysis being done by 2 or 3 master's students, for example. The questions are scalable. So what's the key elements of one of these stories? Well, there's a whole bunch of different key elements, and so we're going to go through these in detail. So that's just gives you some ideas of what's coming next. And the key point is, let's start off with each section. So the first section is problem. It's where you articulate the scientific or technical challenge that your software addresses. Every project begins with a problem, but we very rarely write it down clearly or keep it updated or maintained in a way that somebody else coming in will actually go, ah, no, that's still definitely linked. Over time, it can become implicit, embedded in the code or the workflow. This section brings it back to the surface, and it's surprisingly revealing. Sometimes the problem today is not the same as the problem that the software was originally built to solve, and that gap is important to recognize. If it started off as a piece of analysis and it's become a prototype tool, or if it started off as a prototype tool and it's become a piece of infrastructure, somebody might not have realized as they went through. Once you start writing these things down, it makes a difference. So the next is community, and it's the user community. So this is the people who develop the software, the people who use it. It's not just a list of names. It's about understanding the roles and relationships. Is it built by a single investigator? Is it one PhD student? Is it maintained by an RSE team? Does it have external contributors? Are there distinct user groups? Who relies on the outputs? This is crucial because software is fundamentally a social activity. Software programming languages are written for humans. They're not written for machines. They're written for humans to talk to machines, but fundamentally to talk to other humans. So most problems in software are not technical, they're organizational or communicative. Understanding who is involved and who is missing is often half the battle. Then we come on to technical aspects, and this is where you describe things like the core technologies, your languages, your frameworks, your dependencies, the operating environments, all the usual things you might think. But it's not meant to be exhaustive. Don't list every version number of library. It's kind of like, which things does somebody need to understand in order to engage with this project? What's the key tools that it uses in order to engage with this project? And it helps you understand what the software is and what constraints it lives under. This is usually the shortest section, as it provides the essential context. It tells readers what kind of ecosystem the project sits in. Software practices. This is where you capture the processes that keep the software alive. How do you manage code? Do you use version control? Do you review changes? Do you test things? How do you communicate? Many research groups do far more than they think here, but it's often informal or habitual. It doesn't get written down. This section can help make that invisible work visible and make people go, oh, that's why I'm overloaded. I'm doing all this other stuff as well. And if there's other gaps, almost all projects have gaps. It helps you notice them in a constructive way. And then we can, again, another section is on tools. This is about the infrastructure you rely upon. And this also helps other people see good tools to work with. Do you use version control platforms? Do you use containerization? Do you use continuous integration, build systems? What sort of cluster environments? Do you use workflow managers? Do you use things like Workflow Hub or Galaxy or things like this? Do you use local scripts? You don't need to list everything, but naming the key tools helps others understand what the software is built, how it is built, where it lives, and how it moves through the research environment and why it's used. And that's the important thing. We're using these tools not for the sake of it, but to make our work and our research better. Again, then we can move. There's a section on fair and open. For those who haven't come across the terms fair beforehand, because it's not a term that's widely used outside academia, and I promoted this beyond academia. Fair means findable, accessible, interoperable, and reusable. It's increasingly central to modern research practice, and many software projects already align with FAIR principles without realizing it. And this applies whether it's in an academic and public environment or whether it's in a private environment. These are the things that you need to be able to do in any environment. This section gives you the opportunity to make this explicit. Is the code public? Is it private? Does it have a license? Are releases versioned? Are data formats standard? Do external users know how to access it? Do they know how to interoperate with it? Do they know how to use it and reuse your code? This won't be perfect. You just need to be honest about where you are. Documentation, again, it's an area whereby lots of people go, well, why do I write documentation? And one of my rules of thumb is often if I have to explain it twice, I should capture the second email as documentation as a minimum, as a starting point. But actually, there's a much better structured approaches you can take. And of course, this might be as simple as a README, a wiki, a handbook, examples, notebooks, or even a video. The aim isn't to write the documentation, but to describe what actually exists and what doesn't. You might go, actually, no, we probably should do a whole load of extra documentation at this point in time. And that's good. And it's surprising how much documentation a project has scattered across different places. And it's useful to have to gather that all into one spot, especially when it is scattered across multiple places. Sustainability. Again, this is something which people tend to think of at the end, but it actually covers things like governance, but maintenance plans, long-term prospects. What happens when the money runs out? Does it just disappear, or does it get put on a shelf so it can be taken back off a shelf by someone else? Can it be reproduced in the future? And can it be reproduced 5 years, 10 years, 20 years down the line, which might really matter if you've got things like medical drugs? The point here isn't to force you to take a strategy, but to think about what strategy you do have and to capture this so that somebody, either you have got a good description of it for someone else joining your team, or so that you think about what somebody else can learn from your process, or so that you can actually have a better one yourself. So that's what the whole thing becomes. It's not a technical manual. It's not a publication. You could publish it if you wanted to. You could put it on Zenodo if you wanted. But the idea is that it's a clear, honest description of the project as is, not idealized. And so it's short, it's factual, it's accessible, it's easy for people in any domain to read is the idea. And it creates a shared language at the end of the day, having that shared format. So I shall now move on to the third section. At the end of this section, I will ask if there's any questions, but I'll probably take questions at the end after the fourth section at the end of to take us towards the end of the hour. I'm running a little bit on the slow side.
Okay, Michael, there is already one question in the chat where we can take it afterwards.
Okay. Right, so I can't see the chat at this instant, you say, that's why I'm saying that. Is there still?
Do you want me to read it?
Okay. I can see it now. I'll come back to that later, if that's okay. And I'll capture about where you can store the stories. Yeah, these are good questions to take at the end of this first section. Keep those questions coming. Okay, cool. So this is why write research stories. So we've talked so far about what a story is, and we've explored on a very high level what the template looks like and what structures it. And I want to turn to the more fundamental question: why would you even write one? And this is quite a harsh thing to ask, because I'm here saying you should write these, but actually it's a fundamental question. There's no point writing it just for the sake of it. So why write one? To answer that, I always start with the same point. Who is it for? Because if we can identify who benefits, pretty much everything else follows naturally. So let's name the audiences, talk about the what, the why, and the how, and how that will all tend to fall into place almost automatically. So I'm going to focus on a bunch of different groups with 5 specific audiences who are actually involved. And so specifically researchers, the domain experts whose research depends on the software. They're the key people in all this. Early career researchers. So this is students and postdocs who inherit and extend that work. The early research software engineers or software engineering teams, or etc., R&D engineers, the specialists who build, debug, and improve and stabilize research software. It might be going to standardization. It may be going to productization. You've got managers and coordinators, the people who shape the project direction, resources and planning, and the funders, reviewers, and evaluators, the people who need to assess the credibility, plausibility, and the impact of the work. So this is also why I always start with who, because it tells you what the issue is, what they struggle with, when the story is most useful, and when a story might actually help them. So for researchers, the story whose research actually depends upon the software. So Researchers, scientists, scholars, analysts, these are always the core audience. Their priority is not the code itself, but the research the code makes possible. They want to produce trustworthy and interpretable results. They want to do so efficiently. They want their research to be trustworthy, so it has to be reproducible. And they want to do all this without it falling apart after a few months when somebody tries to change things. There's lots of context. So researchers are often jumping between things. They can be jumping between teaching, writing, travel, conferences, supervision, and the actual research. It's easy to forget where a particular script was and what its assumptions were, why a workflow was designed the way it was. And when they return after a gap, they can spend a huge amount of time trying to reconstruct their own mental model. And this also is a problem when it comes to when somebody new joins the project, because they have to articulate why those steps exist, why the data is handled in a certain way. And when that explanation is incomplete, onboarding becomes frustrating for everyone. Reviewers, especially critical ones, will often ask questions about the assumptions and design choices that these researchers didn't realize needed writing down. So again, this helps with explaining it to others at the end of the day. So it gives researchers a structured way to explain things to the collaborators instead of diving into folder structures or notebooks. You can start with a high level picture, what it's for, give them the lay of the land, what the problems it solves and who uses it. It's a memory aid because the act of writing forces you to articulate the things that you might otherwise forget, especially if you do it with someone else who is not directly involved with the project, which can be really useful if you do it in that situation. We'll come to this. And it becomes a reference point when they are writing method sections for grant applications, for example. So instead of having to rederive the rationale for the software or copy and paste something from before the work was done, they can draw on a living experience directly from their own story. And again, this is how it should be practical for researchers. It provides that structured mechanism for new collaborators. Sorry, I seem to have duplicated my own thinking there. But yeah, so I've already talked about this. Sorry about that. I jumped ahead a little bit. I've got my notes in a separate window and I'm kind of working through those. So researchers tend to rely on stories, formal or informally captured at key moments. And they do this all the time. It's natural. Humans are storytellers. This is something which is so common. And some people forget. You tell somebody a story about the why something was developed, they'll understand it. If you just tell them a bunch of facts, they'll just go straight in one ear and straight out the others. So when you're preparing a grant proposal, a good story gives half of the software justification section immediately. It helps with onboarding new postdocs. It helps with handing things over. It helps with those initial first meetings. It gives RSC exact context and saving days of discussion. When producing odd results, the story cushions them from having to reconstruct their own thought processes. Ultimately, the story helps researchers capture their purpose and assumptions and dependencies in a way that the code itself can't show. And that's what keeps their science reproducible, understandable, and defensible. Now, in terms of early career researchers, these are people who join this sort of work. These are the people who are most affected by the absence of this sort of information, the absence of context. They're bright, they're enthusiastic, they're ready to contribute, and they go, what do I do now? And they hit a brick wall. You don't want to do that, obviously. And they are often parachuted in software ecosystems that are grown organically, sometimes chaotically, sometimes structured. It will vary very heavily depending on the domain you're in and your environment and how software engineering the people are, for want of a good word, and when people operate under pressure. The challenge is not the lack of ability, especially with early career researchers, but a lack of orientation. So the challenge is that they're often dropped into these large code bases, potentially full of scripts, some vague verbal explanations, possibly a thesis from the previous person. They're expected to produce results quickly, and no one has, and it might be that no one has articulated a bigger picture for them. They might have done, but it will vary, and how software fits into the research questions, who uses it. And the point is that different parts of these stories will be missing in many situations. What assumptions are baked in, and what would break if they make changes in a certain direction. And that's one of the fears that people have when they first join a project. Am I going to break things? So they need a starting point that gives them that starting point for a conceptual level. They need to know what the software is. They need to understand what it's for before they dive into reading the code. They need to understand the scope of the project, the conventions that the group relies upon, and which bits are considered safe to change versus core aspects of the project. And it just gives them that starting point at the end of the day. And it gives them that overview that they lack, and it bridges that gap between being new and being productive. It helps them to avoid weeks of reverse understanding, and it also gives them the confidence to operate independently, because then they understand not just the code but the purpose behind it. Now, oops, where are we? It can also help them support their transitions when joining a project, when they're finding their footing, especially when working with legacy code, because legacy code might be 5 years old, it might be 20 years old, it might be 40 years old. It may not be well documented, and it matters when they're switching between related subprojects to be able to reframe their mental model quickly. It helps them when they're writing their thesis, because they need to articulate how the software supports their research. And it also helps their skill growth. It helps them move between someone who's starting through to somebody who's being confident, somebody who's been confident modifying the code and becoming the experts themselves. And it helps boost them along this chain, because they can quickly see the different parts. And I think it's just useful just to capture that as a detail. Then we get people who are more like me, people who are software engineers primarily, who work in research and perhaps led and built various different research systems themselves, but they are in the situation they may be brought in as a software engineer. So these are the people who are brought in to fix, build, and support research software. They often arrive at a point when things may be fragile, they may be unclear, they may be asked to help make this work without huge amounts of context. They might need to understand the scientific intent behind the software, what the constraints are, what workflows support it, and the assumptions and the communities that depend upon it. Fundamentally, they need a good conceptual model, and again, until they can construct what the software is for and how it fits into their research, cannot design good solutions that are safe and sustainable without a good conceptual model. They spend a lot of time guessing which parts are critical and which parts are incidental. And that guesswork is expensive. By having a research software story, it helps answer questions you spend weeks or weeks, or sometimes months reconstructing. It explains what the software is meant to do and how it supports the science, what constraints matter and what compromises were intentional. It tells them what success looks like from their point of view, allowing them to propose solutions that are aligned to actual scientific goals. And again, it helps when they're joining midstream, debugging unfamiliar code, estimating feature work, and planning and refactoring. Now, again, it also supports development for RSCs. They can learn the context. Competent RSCs can start identifying missing components. Confident RSCs can propose improvements, and expert RSCs, if they're given enough information, refine the architecture with respect to research goals. Like, this is a good way of taking advantage of this cluster of GPUs, for example. And this might be a better approach for writing this particular piece of code in order to do this. But the different scales, you will have different RSC with different RSC levels, and you need to be able to give them the same information. They will get different benefits from the same stories. And so in this particular case, the connection to RSQKit is that if the stories link back to RSQKit, it can link back to the specific tasks. It can link back to things like how to do documentation. It can link back to, this is how we do workflows. This is how we do licensing. This is how we do testing. And those links into those tasks, and it also helps somebody else come along and go, oh, so that's the reasoning, and this is what I need to do. This is what I need to understand in order to manipulate this further. Managers and support people who are supporting fundamentally the work. Managers are there to support people and get, in my opinion, to knock down barriers and make sure things are working for people to actually get the work done. And these are often the glue holding these projects together. And even if their work isn't visible in the code, they need to still understand the same things, because they need to plan timelines, coordinate staff, handle reporting obligations. They need to understand that this is the reason why we need 3 extra RSCs to work on these bits, because this problem exists in the structure of the code, or this problem or opportunity exists based on this code. Both are good reasons for bringing people in, problems or opportunities. And in order to do that effectively, they need to understand what the software is and how risky or fragile it is. And risk management is one of the key things which I think this helps with for them. So again, it depends on the software, how sustainable it is, what risks exist. Like, for example, is there only one engineer or only two engineers, or is there only junior engineers, or is there only senior engineers, which is a similar risk for different reasons? And what bottlenecks appear? And so the stories support this coordination between the different groups. It gives them a single authoritative review. It can be used in planning meetings between different teams. It can help with coordinating interdisciplinary teams and negotiating priorities and deciding where to allocate RSE time. It can help identify staffing needs and training needs, and gives a way to track how the project evolves over time without needing to go over every technical detail. And obviously it can assist in transitions, which is something managers have to deal with: new team members, departures, new funding stages, and annual reviews, institutional reporting, consortia reporting, project transition between project phases, team members leave, and so on and so forth. Having this information enables consistency over these times of change. And funders and evaluators, something we don't, as I say, talk about very often, but it's vital here because their job is often to decide whether work is worth funding or doing. And this group rarely interacts with software directly, and their influence can determine whether a project lives or dies. And they need to understand the community it serves, the scientific value it enables, and the sustainability of the work. So they're not looking at the code, they're looking at credibility. And so, again, this comes back to the same key points: purpose, users, value, and sustainability. It's the same sets of questions over and over again. And this is the reason why it's worth going through the individuals. This kind of explains the reason why these things exist. So this credibility, the research software story speaks to the credibility of this. If somebody says to you, "Can you tell us about your story?" you give them this, it's significantly more credible than having to scrabble around for lots of different sources of information. It explains the scientific relevance and the key rationale behind key decisions. It outlines the sustainability plans, even if minimal, and identifies risks openly. And fundamentally, that means you can evaluate the feasibility, reliability, impact, and resource allocation needed for a particular project. Now, there's also some cross-cutting benefits, which are fairly obvious as well, about securing reproducibility. But we've talked about things like onboarding, we've talked about misunderstood assumptions, about reconstructing context, about repeated explanations, and this goes cross-cutting across so many different things. And the stories reduce that friction. So anything that reduces friction makes life happier for everyone. And I think that it doesn't need to be long. And that's the example, that's the reason I started off with by showing a couple of these. It doesn't need to be long, it just needs to be clear, and aligns the purpose, the assumptions, and the workflows, so you can rediscover your meaning later. They also can help guide improvement, because in the process of writing these things, you start realizing, oh no, we've got missing documentation, we've got missing description of our workflows. Actually, we don't do our workflows in a reproducible way. Maybe we can use GitHub Actions. You can start thinking about these things as you start doing these things, and it helps give you the why behind those decisions. And also, these whys are the most vulnerable to being lost when people move on. And so ultimately, I think this comes back to why research stories, because at the end of the day, they preserve the why behind your decisions. They protect your content against context loss. They help support your project. The people who fund your project, they reduce friction, they increase clarity, they strengthen collaboration, and they make your software more reproducible, more trustworthy, more reproducible. It makes the implicit explicit. And so let's move on to the final section, and then I'll do the questions, I think, if that's okay, and with a quick walkthrough of what's in one of these templates. Thank you for reposting that link again, which is great. So yes, the recording is will be shared, I assume, afterwards. Previous ones have been shared on the EVERSE YouTube channel. Saw that pop up at exactly the right instant on my screen. That question. So, research templates. So, this is a walk through the template. Now, before I dive too deeply into that, I will just quickly show, actually, two versions of the template, because we have two versions, one which is an empty one, and one which has got a whole bunch of prompts. Now, the one with prompts is intimidating because it looks like 7 pages of text, and you go, "Well, I'm not going to do that." But if you actually look at the short version, it's half a page of text. It's just a bunch of things that you need to answer the simple, obvious questions for. So hopefully that's not going to be too scary when we come to it, but I just thought it was worth briefly showing that. So this is where we're at. And there's my notes. There. Right, so now we've done that, we're going to talk through how you actually write one of these things. And the point about this is we've already got a template, and that's the whole point. You could have your own template. You could do this any way you like. You don't have to use our one and use our approach, but the who, what, why, where, when, and how are just absolutely vital to be able to capture. And there's slightly different nuances about which different angles you look at things, some of these things from. And capturing that is very useful, and having it as a step back is really useful. Having a standard structure is really useful to be able to share these things across different domains, because whilst the science and the research or whatever may be very different, the techniques and tools used to use them might be almost identical. So, for example, if you're doing broadcast research, containerization and workflow systems and clusters are very, very useful. But they turn out to be extremely useful if you're doing HPC and simulation. They turn out to be useful if you're doing biological DNA related things. So you can tell I'm not a biophysicist, biologist, can't you? So this is where we're at. And so we're going to talk about how you externalize the context. So this is going to be roughly a quick walk through the different pieces. And it's a first impression of what the idea is, what this is to look like. So we're going to go through this in order. And as I said, you might look at it and go, this is a lot. But the idea is to understand the purpose behind each of the different sections. So, and what kinds of answers are useful. And as I said, it looks like a lot, but actually it's not so bad, especially once you start doing it. So a template is very much, think of it as a thinking tool. The template doesn't demand perfection, it just prompts the right questions. So the most of the actual, those 7 pages of that, the version, are basically a bunch of questions that you might want to think about, and you then delete them, the ones which don't make any sense for you. So section 1 is the problem. So the first one is deceptively simple. It asks you to describe your problem is looking to solve, ideally with a single one-line subtitle summarizing it. And this is more meaningful than it might appear, because in research environments, you might dive into explaining everything first without stepping back. This stepping back forces you to articulate the scientific, analytical, or operational problem that motivated the software in the first place. So what you want to write here is something which somebody who is outside your community will understand. Be straightforward. Describe the challenge, the key bottleneck, the inefficiency, the barrier, the reason for its existence in the first place, and the problem. And in plain language, preferably without jargon. And the problem matters because it helps define the project. It defines your scope, it sets expectations, and without that clear statement of the problem, it can be very difficult for collaborators or contributors to understand just what the software is trying to solve and what it's not trying to solve. And the research software here begins because that's where pretty much every single decision point flows from. Next one is who, so user community. And again, this is about who builds the software, who uses the software and people who use it. And ask for a brief we ask for a brief subtitle, and we ask this across all the different sections because it can help with reading, but you can always add the subtitles in right at the end for each of the different sections. And you can essentially then expand into the different sections. So you can talk about how the development is organized, who relies on the software, what range of backgrounds they have. Is it collaborative code base? Is it maintained across multiple different institutions? Is the software developed by a single researcher in their spare time? they're all valid models, and writing it down helps other people understand why your project works the way it does. And describing that unit of your community, who depends on this software, how experienced are they? Are they domain experts with minimal programming experience, computational scientists comfortable reading code, or are they postdocs or students or senior researchers or very junior ones? Are you throwing it at undergrads? Knowing the audience helps readers interpret the rest of the story correctly. And a project used by a first-year PhD student might require very different onboarding from something that's used across 20 different institutions. So then the next session is technical aspects, which kind of describes what the project is technically, rather than the human context. And in this section, you're describing what software is that you're dealing with. So you're talking about what software tier in RSQKit terms is, and EVERSE terms is. So is it analysis code? Is it prototype code? Is it infrastructure code? Is it nascent? Is it mature? Is it something service oriented? It leads you into discussion about languages, about complexity, about history, and deployment environments. And it helps the reader to understand just to understand the concept, the high-level context, what the maturity is, how fragile it is, what's the scalability and the amount of effort that's required. So, for example, if your cluster is requires specific cluster configurations, GPU access, that matters. If it's a small library that runs on a laptop, that's useful to know as well. Something that's 1,000, 20,000 lines versus 1 million lines long is very, very different. And conveying that stuff is really useful to capture from a single space. So, related to this is libraries and systems. And that's a simple extension of this, by again, you want to capture the high-level libraries and systems you rely upon. So you might say, well, we use scikit and this, that, and the other, but you're not going to mention things like Python and CSV libraries and these sorts of things, because these are sort of like fundamental infrastructure that you rely upon. You say, well, we're in the Python ecosystem, and its specific libraries we rely upon are PyGamma, for example, and so on and so forth. And it's useful for people outside of your field who may have heard the names but not know how they fit into your work. And that's the key point. It's not just a list of things, it's a list of search terms, and it's a list of key reasons as to why these things are used. Now, from an EVERSE perspective, the software quality practices is probably one of the more interesting parts, because this is about not just about how the software is developed, but also the culture around the code. Now, what to include here is, do you include things like version control? Yes, you include things like licensing, contribution processes, testing, continuous integration, release workflows, and it describes all the different processes that you use and the tools that you use to do these things. You might not do all of these things. That's fine. It depends on what is appropriate for your project. But these are things that you might find useful. And having these as questions might make you think about, oh, maybe we should be using continuous integration. Maybe continuous deployment makes sense for us. Maybe it makes no sense to us because we're doing hardware development. And we're doing firmware for hardware development. And so you can't do always continuous deployment onto hardware embedded systems. So even if the development feels informal, chances are that some practices will exist, and writing them down helps make these things visible. Now, this matters again because it helps people when they're joining, reliability, and all the same reasons we've talked about beforehand. It tells collaborators what to expect when they're contributing to your system. And if you have a formal review system, it can help newcomers before they join. And this section helps highlight the benefits that developers have gained from using those specific good practices. They're not using them for fun. They're not using them for the sake of it. They're using them to make their lives easier because they want to go home and see their kids at the weekend. They want to be able to play with family and so on and so forth. Now, some good questions coming through, which I'll get to in a bit. And whatever the case is, this section fundamentally helps situate the project in the context of the broader culture of research software quality. Then we've got the people who build the stuff. So this is about the people making it. So this is about how you get people on board. This is what happens when new developers join. What processes do you use? What processes do you help to let new users learn how to develop with the system or library or toolset or infrastructure that you have? This is the space to capture all of those sorts of pieces of information. And it's useful because it tells people what to expect. And every project has repeat patterns about the typical user who wants to achieve certain things. You have students who want to run a standard workflow. You have senior researchers who want to adjust parameters. You have external collaborators who want to use just the subset of your features. Describing these makes your software more clear and more accessible on how mature the project is. And it helps give funding insight into funders into how mature the project is. If somebody's got a good description of this is how you bring in not just individuals or qualifying tasks, but this is how you bring in whole institutions and whole organizations, it speaks very differently to project maturity and therefore take up of your system or tool or project or analysis system or whatever. And then we talk about the tools. So the tool section was where we talk about tools to support your quality. So this includes things like linters, formatters. Again, CI systems fall into here as well. Profilers, though, metrics things. There's things like CodeSense and various other sorts of tools that exist out there to identify problems in your code. So things like containerization, workflow orchestration. It also includes things like archival to an extent, but that interacts with sustainability. And again, the tools matter because it's not about listing everything. So you might have 10, 20 different pre-commit hooks. So just say you use pre-commit hooks, don't list them all. But say why you're using them, like to prevent accidental errors. If you're relying on containers to avoid drift, that's great, but you don't need to list every single container. And if your CI system runs regression tests, mention it because that's the purpose of its existence. So it's not just the tools, it's why they do it. So it's not what you do, it's the way that you do it and why you do it that matter. And again, RSQKit can link to lots of different things that support descriptions of these things. So you don't have to write everything yourself. You can just link to say, we use this to fulfill this task. Now, fair and open, again, this helps people understand where it sits inside a wider research ecosystem. Is it open source? Is it not open source? Is it closed? Is it something which is interoperable with inside an organization or within multiple organizations? And it simply helps you to explain how far along this process you are. And there's a whole bunch of different things that which you can address here, from public repositories, like citations, licensing. Is your code citable, for example, issue tracking, contribution visible? There's a whole bunch of different things. And I could go spend out ages on this, and there's not a lot of points because there's a lot of different details to pick up here. And I just want to cover the overall aspects that actually you should be thinking about when you're filling in these sections. So the reason it matters is they help increase trust, reuse, uptake, and visibility of your research. So if if 5 people are using the same tool set as you, they're more likely to see your research because they're going to be interested in seeing who else has used this software to produce this thing. And that means your research then has greater visibility. Your papers have greater visibility. Your papers are greater citations. And the point about this is that this isn't about perfection. It's about capturing that moment in time when you write the document and perhaps when you update it. So it's being about honest and about visibility. Yeah. So likewise, the same goes for documentation. It's how people learn and develop your software. I'm running a little bit behind, I'm afraid. So I'm nearly at the end of this section. So please bear with me. There are 10 sections of the template, and I am scooting through them quickly. I did practice this, but I'm obviously speaking slightly slower at this instant than I was when I was in my practices. Right. So if people do need to drop off, apologies, but you have access to the links and the handouts have everything. I'm going to keep on going and then take questions, and then there's a little bit of buffer time in the second hour. So documentation is a section people often worry about the most because it feels like an admission of guilt, because they didn't want to write it in the first place, because they want to focus on the research. The software engineers wanted to write code. The researchers wanted to do the research. But the template handles this relatively gently for you. You don't need to claim perfection. You can state plainly and openly that your documentation is minimal and scattered, or it's still being developed. You can state you've got a README as an entry point, or that you maintain a wiki, or that you provide hands-on examples. Documenting where that documentation is really helpful in helping others understand how to begin and interact with your project. The 3 stories that I wrote initially, which helped kickstart some of this work off, were 3 projects I had no prior involvement with. They helped me understand these projects, which is why I'm able to say, actually, no, this is really good. If this had existed beforehand, it would have been bootstrapped. So just worth bearing that in mind. So again, we talked about what sort of things, and again, it's about the honesty about the documentation. It doesn't need to be perfect, but it needs to be honest and correct. Now, when we talk about sustainability, what goes in here, we're talking about things like governance, formal and informal, what your funding levels are, how the project maintains its activity levels, its maintenance responsibilities, and plans beyond current grants. So in this section is mostly about research projects. This is the bit that lots of research projects try to avoid thinking about, because this is basically a bit of saying we might not last forever, or we have this aspect of our project is immortal, it's going to keep on going forever, but it's not. It's going to end at some point, or it's going to mutate, or it's going to change. But so this is something which sometimes can feel like important to think about later, but actually the sooner you think about it and capture it, the better. So we're talking about maintenance plans, funding sources, plans beyond current grants. Is your project moved forward by repeated PhD students? Is it moved forward by repeated MPhil students? Is it moved forward by some funding that's come in from a large EU grant that covers a number of different engineers? Or is it a targeted thing from, say, the Innovation UK, for example, that's a specific targeted short time frame? And again, it's about, what do we capture here? We don't, at the end of the day, it's about just capturing these things at an appropriate level that is relevant to your project. So that's probably the key points from there. I'm not going to, I could labor the point. I'm not going to. Lastly, references. There is a section for references. Academics love references. Academics get very upset if references aren't there, in my experience, and quite reasonably so. But this is not a paper, so there shouldn't be hundreds of references. This is meant to be an introduction to somebody to coming in. So rather than sort of like having a paper where you might have 20, 50, maybe there's sometimes a ridiculous number of references that somebody will cite. What's the key ones that people actually need to know in order to understand your things? So if you're talking about, if you're doing workflows, you might want to link to, this is how workflows operate. If you're doing something that's to do with a particular style of research, like to do with entity component systems, you might want to link to a canonical piece of work on that particular thing. Or if you're talking about the actor model, picking a couple of topics I'm interested in, you might want to link to the specific things that you're actually using in that research software, rather than just the general concept, because you can assume that somebody can go away. And it helps place your software inside the wider research environment. The references should be software oriented. So lastly, bringing this all together, what it does is it captures all the things you already know but haven't noted down, the context your collaborators need. And the aim today is not to finish the story, but to begin, and to let the template ask questions that strengthen your research. So that's a whistle-stop tour of the various different the who, what, why, and how. And now I will go to questions, and then we can take a 5-minute break and then come back. When we come back, I would like to have I'm going to ask for a volunteer. So I will stop sharing for a second so people can see me, and I'll go to the chat window.
I can help you if you want, Michael. I can read those questions out loud for everybody. It helps. Because I've been following. Yeah. So we have Michele and Andrei basically asking more or less the same thing. So where the story should be stored, as the software evolves, how the story should be kept up to date, where should ideally this story live in a wiki, in a README format?
Yeah, this is a good question. But where do you want to put it? At the end of the day, the context for us is we're inviting people to share their research software stories with us. So if you would like to leave donate your research software to us, we open a pull request. put it onto EVERSE, and I'll help you get it onto our system as a useful case study that can help other people learn from you. Because that's one of the key things which we want to be able to do with EVERSE, is be able to capture these things. But if you want to capture them internally, then one thing you can do is you keep it with the key project documents that you know that people will always go to. So I personally have a structure which is where I have projects and I have stuff to do with sections which is to do with code, and I link the two together. So you don't have to. I don't think there is one fixed place, but it's the place where's the one place in your organization people are going to look first? Now, are they going to look in the code repository if you have just the one code repository for it? However, if more realistically, you might have 4 or 5, you might have a project site, and your project site might be a SharePoint site, it might be a wiki, it might be a Confluence, it could be various different things, and you can situate it with it. The point is to put it somewhere where it's going to be useful and easy to update. And I think keeping it up to date is one of the most important things, because then it's going to be at your fingertips when you're applying for extra funding, when you're applying for a new grant, you can pull it in. When you've got somebody who joins, you've got it accessible. So that's probably the key point I would raise for that.
Then we have Anelda asking about, yes, all of this sounds like metadata that could be invaluable in all kinds of ways. Have you thought of creating this app as a metadata standard and suggest a way to make the information also machine readable?
Machine readable, yeah, I see the question. I can see the point. I mean, you can think about using things like code meta to capture the same sorts of information. But the point about this is that it's a human readable document. It's a document primarily for people in the first instance, and its intended audiences are specifically people to be brought on board. Yeah, you could definitely reference it in code meta. You could say this is a reference to where our research software story is. Can raise that with the code meta people because we're in close contact with them. So it's a reasonable question, but I feel that it's a slightly sideways question as well, because the point is that these are human readable for people to be able to be onboarded and be able to do things, as opposed to primarily for machines. Hopefully that answers the question. I'm not saying no, but I'm saying it's not a primary focus for us at this point in time. Okay, so I'm going to stop questions there at this point in time, unless there's somebody got a burning question which I haven't covered. If there is, ping me in the chat. For the moment, what I'll do is I will suggest a 5-minute break, because
yes, and
people need breaks.
Yes, we also do.
Yeah. So what I'll suggest is if we come back at 4:15, I'll leave this up on the screen, which has got a link to the support materials. There's my Zoom. Oh, there it is. There we go. So I'll leave this up on screen. It'll actually. Yeah.
And so we rejoin with those that want to follow the guided writing session at 4:15. Thanks.
Yeah, I shall. Right, I shall dive straight in. And what was that? Don't say. I've gone through that. So we now move on to the final section, which is about how the guided writing session. Now, I'm just going to scoot quickly through the slides so people know what I've got here, so they've got an idea of what I'm going to do. I'm going to take this section is going to be different from the other ones, but I just want people to have an understanding of what I'm planning on doing here. Now, this is also going to be slightly different from the way what somebody means by guided writing is going to be different from one person versus another person. So that's the other reason for wanting to cover this at this point in time. And it'll become obvious as to why this is also why I want the transcript session switched on. So the idea behind this, and as I said, I'm just going to scoot through this. We're currently now in the second part, so we're going to talk about a guided writing session and Q&A, and we're going to take about half an hour on this, maybe, because there's 10 sections. It's about 3 minutes per section as the idea, and with a little bit of top and tailing. So at the end of this, I'd like it to be people to have the idea of a first draft of your research software story. It won't be perfect, it won't be complete, but it'll give you the first 2 to 3 full sentences, hopefully, for each section. Then maybe some short bullets if you're useful. And it won't be perfect, and there won't be any, it can never be perfect, because you can always refine things. So capture what's true now, not an idealized future. If you think what you're doing it and you think actually it would be useful to do this, you can write down, ideally, we could also do this, but capture what's true now. And the way to approach the session hour is we're going to move section by section, spend a few minutes per slide, and we're not going to overthink the phrasing, and write down the things that you wish somebody else had told you when you first joined the project. Not the first things necessarily that spring to mind, but the things that you wish you'd been told. And the slides for this is 1 per slide, and there's a bunch of different questions for each different one. And I'm just going to scoot quickly through them so you can see what this format looks like. And this will then explain what the why between how I want to run this bit of the session. So there's going to be a problem, a user community, technical aspects, and you'll notice that what we've got here is a bunch of different questions. So problem, what, why, what. Lots of different questions. User community, who are the developers, and so on and so forth. All these different things. The technical aspects, these are, again, a bunch of different questions, which are all going to be asked, and these are all the things that you need to think about when you're writing these sections. Again, libraries and systems, a bunch of, again, a collection of prompts to think about and questions to think about. The same for software quality practices, same for developer community and tools, fair and open, documentation and sustainability, and references. Then at the end, the aim is for you to be able to bring your draft together to capture those essentials. If you write honestly, it's going to make life a lot easier rather than wishful thinking. It's very, 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 the reason I say is it's so easy to fall into wishful thinking of, oh, maybe we should do this. I'm going to write it as like that, as opposed to what you actually do. Capturing that's really good. Don't worry about polishing it. Those that say with writers, the first time somebody writes the story, they write it for themselves, and then they rewrite it and rewrite it and rewrite it. You can refine, expand, and shorten later. And then what you should end up with is a final result, which will be a final draft, which you can then iterate. Now, to make this mainly more interactive than just people sitting quietly answering questions and me asking a bunch of different questions, what I'd like to do is actually run this as a more interactive approach. So for this, what I really need is a volunteer. And the volunteer, ideally, there's 2 different possible volunteers at this stage in terms of the way we can do this. One is to have a volunteer who has a research story which they want to write, and they want to make their life easy by doing it the quick and simple way. Which is why the transcription switched on. Or it's if I don't have a volunteer, somebody who's willing to do that right now, somebody who's willing to ask me questions. And I have somebody who should be here, saw them earlier, who said they would be willing to do that questioning. Yeah, there. So do I have a volunteer to answer these questions about a project that they're working on, that they would find it useful to have a research software story with for? I could pick names, but it feels a bit unfair. Hi.
Yes.
Fantastic. J Proctor. What does the J stand for?
Jim.
Jim. Pleased to meet you, Jim. Where are you from, if I may ask?
I'm currently in Scotland. I'm not
Lovely.
from Scotland originally, I'm Southampton. So I vary between places. So my story is quite old, so I know it very well. That's why I figured I'm an easy shill here.
That sounds fantastic. That's what I was hoping for. So essentially, you've seen me scoot through the questions. Now, the way I'm going to want to do this is I'm going to ask you these questions. I'm going to ask you to talk to answer the questions, and I'll probably stop you after 2 or 3 minutes. And that will mean that in the transcript, I'll have all of your answers, and then I can copy and paste these all into the template, and then off we go.
Oh,
So
easy.
yeah. Let me make it so that I can just show people. So what I'm going to do is I'm literally going to just copy and paste into here the answers to Jim's questions. And my aim here is to show that you can do one of these things relatively quickly in about half an hour and have a nice starting point. So let me bring the questions back up. So, problem. What's the name of the software?
Jalview, Jalview.
Jalview. Cool. Jalview, rather.
Yeah.
And what does that do? What's its reason for existence?
The reason for existence is visualizing sequence alignments of DNA and protein and RNA.
That sounds interesting. Can you tell me more about that?
Yep. So before it was developed, there were programs that could allow you to look at these things and look at the alignments, but they didn't really create figures. So it's been around for 30 years, and the reason it was created was firstly to create figures, automate a process that was kind of done manually, and provide a WYSIWYG view of it so you could change shadings and highlight patterns. So it does a bit of data analysis at the same time. The other thing it does is it links evolutionary analyses and 3D structure analyses with the sequence alignment. So that was its core thing, and that's still what it does today.
So are there any key algorithms or techniques that it relies upon for this to work?
So that's a very good question. And I think that's a tricky thing. So the key algorithms it relies upon are conservation analysis and consensus analysis. So basically, it's like a glorified spreadsheet with very specialized data.
It's a really fascinating. That's a fun way of describing.
Yeah, I mean, you can build it out of a spreadsheet. People have done this before Jalview, and they still do.
Oh wow. Okay. So what's what? So you talked a little bit. So what wasn't sufficient about the existing tooling that existed, or
So yeah.
Yeah.
So existing tools didn't. So I guess so. One of the critical things was Jalview became more accessible than existing tools because it was developed in Java. So that's the J in it.
Okay.
So when it was developed in the 1990s, before that you needed a specialized computer. There were PC software that kind of worked. There were Mac software that kind of worked, but they didn't really do everything that was needed. And this was the first thing that came on the web and got broadly used.
Nice. Okay.
So that was the thing.
And so one of the natural questions here, and one of the questions which is here, is what's the boundaries or limitations that define the scope of the tooling?
Yeah, so this is possibly the trickiest thing. So actually, and I'm trying to, I maybe should look at the Baylor example just because that's possible that we haven't really articulated. I mean, there are physical technical boundaries.
Okay.
And there are cognitive boundaries in the use of the tool. So, no, that's really hard, actually.
That's good. This is the thing. It's useful because it's an interesting question. We don't have to answer that now, but that's
Okay.
it's useful to think about, and it's useful for actually you to think about. Yeah. This is what I sort of talked about when I was saying that it sometimes helps uncover different things that you might not have thought about, which are useful potentially for someone else to think about. So user community, you've talked a little bit about this already, but who really relies on this for their research? And what sort of roles and expertise do they have? And what sort of groups use it? Those sorts of things.
So the majority of people who use it in research are people who are not bioinformaticians. They're wet lab biologists who don't code, They know where databases are, they know the websites, but they also know that I mean, if they've discovered JalView, because quite a lot of people don't use JalView, but at the same time, what they use it for is doing this integration of data from different sources and mapping it into this sequence structure function view that JalView gives you. So they are primarily people who wouldn't be contributors to the project.
Oh, that's interesting. Yeah.
Yeah,
Okay.
and we've seen a shift actually. So we used to have people who were contributors who were developers methods to add to the project,
Yeah.
but technologies have shifted, and so this is the situation we're in. I mean, it's a specific thing with a legacy tool as well. So it's been around for so long that it's not pretty hot to make sequence alignment visualizations. That's not cutting edge research,
Okay.
but people still want them. So
So they need the tool, they need the expert things, and so the expertise of the people involved who use it is different from the expertise from the people or a subset of expertise of the people who develop it. Then.
yeah. So actually, we're in a situation where we need a lot more of the sort of commercially relevant research software engineering skills and software design skills, because we have to design for people who aren't us, whereas typical research software is developed for people who developed by the researchers for the researchers.
Yeah, I mean that's one of the questions. So it's more of a tool which is used by researchers as opposed to something which is developed by the researchers. So in terms of the way we think about that, it's we kind of think of that as kind of like research infrastructure, it's a piece of infrastructure from their perspective that helps
Indeed,
support their tooling. Yeah.
Yeah.
But it's not in terms of infrastructure, in terms of a big piece of a big physical piece of infrastructure, but it's a necessary part of their ecosystem.
Yeah. I mean, I think I used to describe it as Word or Illustrator. So it's a generic tool that works with specific types of data. So and that's still kind of the thing. So it's
Okay.
this is why I needed to come to this to fine tune it a bit.
Yeah, that's really useful. So technical aspects. So we've talked about what sort of software it is. It's kind of it's a tool, but it's a tool which is used by different people as it's slightly more like infrastructure to an extent. We talked about which languages you use, which you've already mentioned, Java as the primary language. But how large is the code base, and what sorts of things? What's the technical aspects of the system, constraints that you operate under, data volumes, those sorts of things?
Yeah, so data volumes, it currently works as an in-memory system
Okay.
because it's primarily about interactive analysis. So it does have some it doesn't actually have any sort of distributed streaming capability at the moment. So the code base is 250,000 lines of code.
Right.
I mean, it's Java, so it's bulky, but it's also quite big, even for a Java program. And it's legacy code, so it's developed with frameworks, some of which are not 100% maintained. So we do a lot of maintenance of the platform and the technologies in order to make it work smoothly for people who don't want to do technical things like install Java.
Yeah, that makes sense.
Yeah.
Okay, cool.
And so constraints, so we have a lot of people teaching with it. So they get very upset if we change the user interface.
That makes sense.
So we've got a well-endowed legacy workflow that has to behave the same way, and hopefully we shouldn't have a button that says answer my students' questions for them. That was one of the worst things we did. We made it so it was easier to do some stuff, and then somebody said, "Oh, I've got to completely rewrite my exercises now." Because they had questions about how to go and find the information and bring it into the tool themselves.
That's quite funny. That's a fairly common problem, I think, with quite a lot of tools. It's kind of it's that balance between being a useful tool for doing research and a useful tool for doing teaching.
Yeah. So we're thinking about actually splitting and have a teacher mode and a researcher mode potentially for that.
So let's move on to libraries and systems. So what sort of libraries, frameworks, or APIs do you depend upon, and data formats, etc.?
So we depend upon a lot of the public bioinformatics infrastructure APIs. So
Okay.
Jalvi has clients for all of those, and so those are web APIs.
Can you name a few of them?
Uh,
Can you name a few of them
yep.
for us?
So Emble, EBI, Uniprot, PDB, AlphaFold database. What else do we talk to? Ensemble, Emble EBI Ensemble API as well, and the Emble EBI PFAM and RFAM databases. Those are all go through the DB fetch interface, which is kind of a unified REST service. Some of them are specific as well. And then we also have 3D Beacons Network, which is a distributed, that's the federated structure database API.
Okay.
And we work with those people in order to make sure that it does these things do what we need as well.
Nice. Okay. Now, how long is that? I mean, just before we go any further, how long, you said in the 90s, how old is the project? So if you've been using it for a while, then I'm sure you use a number of different development practices.
Yes. So I believe that version control might have been used right at the beginning in 1995, but it would have been CVS.
Or even
And
RCS.
when
Yeah.
I joined it, yeah, it possibly was RCS. I think, RCS and CVS. I started
Yeah.
using CVS around then as well. So,
Okay.
uh, so I joined it when I joined it in 2004. It was still in CVS, and it was a throwing the software over the wall type open source project where it wasn't even on SourceForge back then.
Right. Okay.
And then we moved to Git in 2010.
Sounds a fairly common route for older software, definitely.
Yeah. And we actually aren't on GitHub either.
Oh, okay. Is it just a local repo, or do you serve a repo, or do you
We
GitLab?
host our own GitLab,
Oh, okay.
and that's so we can run our own deployment and distribution stuff. I mean, now we can do it because you can do local GitHub action executions. So you can run GitHub action agents locally, which for us is a critical thing because we need to be able to provide keys and so on, hardware signed keys for. We have to sign the code to make it run without scary warnings, basically.
That
And
makes a
all
lot
of
of
that was
sense.
quite difficult to do up until relatively recently, actually.
Yeah, because local GitHub runners is a relatively new thing.
It is, yeah. GitLab was the only one that provided it before that, and Atlassian before that. So,
Okay.
and I guess here one thing I guess is relevant is sort of the size of the development team, isn't it?
Yeah, we'll come to that in a moment because
Yeah.
that's kind of one of the next thing, as I recall. It's not quite the next thing; it's two things down. So we'll come to that in a moment.
Okay.
But you can mention it, please do.
Yeah. So code review, we do code review. The primary gatekeeper though is me, so I'm the bottleneck.
Right.
But,
Okay.
but we do. So we're a 3-person team, so we do sharing. We have continuous integration tests. Our release processes are documented. Sometimes we still get them wrong. We released with a glaring bug a month or so ago that we're just finally fixing. Decisions are made by so the project lead is a PI who doesn't do any coding.
Okay.
And I'm kind of like the co-lead. So day-to-day decisions are me, and then overall directions, product owner type decisions are made in conjunction with the PI.
That makes sense.
And then how do people communicate about changes? What do you mean by that?
Well, that's a good
Changes in
question. I mean,
practice?
that's a fairly reasonable thing, because you can talk about, as you say, what do you mean by that is a fairly good question.
Yeah.
You can sort of communicate about changes using things like Slack. You can use something like pull requests. You can use
Right. Okay.
DMs.
So
You can do merge
changes to
requests.
code,
Yeah.
but not procedures.
Yeah.
Yeah. Yeah, so we
Okay.
use an open. So basically, we use Gitter,
Okay.
a Gitter forum for main communications, and we have a discourse forum, which is more asynchronous.
And do you capture things from the Gitter forum and turn those into issues and capture them or turn them into documentation? Because I've seen some people do that.
We do sometimes, but often we go straight to the issue or straight
Okay.
to the documentation.
Okay. So you started mentioning about developer community. You mentioned you've got three developers.
Yeah.
Based on the user base, do you have many external contributors, or would you like more external contributors?
We'd always love more external contributors. I can't believe any project would say, would say no unless they have too many. There is a point
Yeah.
when you have too many. So we often have student developers who are doing a project.
Okay.
So those are the most common developer. So often it is somebody new to the whole thing, and once they get over the shock of waiting for 5 minutes for the GitHub repository to clone, for the Git repository to clone, because it's a very big repository. We've got some
Yep.
stupid stuff in there. If you look at some of the branches, somebody accidentally committed a VM, and I don't think I've pruned that yet. So um so so
Just
yeah.
as an aside, at that point, Git subtree can help you with that, just in terms of cleaning up and getting rid of big things for what it's worth.
Yes, yeah, I've already done a lot of Git surgery, so this one I plan not to do for a while, but it
Okay.
will happen at some point. You
So
don't.
yeah, so what do new contributors do first? I mean, do you have? I mean, if you have students who come in, I assume you've got tutorial examples and things like this.
So the first thing people do is they use the actual JalView exercises. They actually use the tool to understand what it does, and I have to say that some of our very good contributors still probably don't know how to use the tool. So it's not a requirement, but it does help because it gives you contextual understanding, particularly with a GUI application where the flow is not obvious, and it's not like there is a clear route from beginning to end. And once they've what at the same time they'll also we've got some basically onboarding documents,
Yeah,
which point out everything you need to do, going through procedures of no commits without an issue, which was something that predates pull requests, and that's possibly some of the things of
yeah, that was a
you
very
have to have
common
something
practice
to
back
write
in
in
the day.
your Git commit apart from what you did.
Yeah.
So it gets tagged to things. And then they usually, even though they're doing that, we've got kind of a top level summary of what goes on in each package, so people can drill down afterwards and explore, because they have to start to grok the code. But my role then is that I mentor them in that case.
Okay. So you get to see the obstacles they face up front and personal in that case.
Yes, and I do apply the if I've said it once before, I try to document it.
Yeah.
So we used to maintain a wiki. Now we have, I believe, a Google Doc which is sitting on the website somewhere.
Okay.
That stuff.
Okay. I'd love to spend hours talking about this, but I'm aware that this is an example, not an example guided walkthrough for people. So
yeah.
Hopefully this is useful to people who are listening. I'm finding it fascinating, but hopefully this is useful for other people as well, because the purpose of this exercise is to capture what's being said so we can copy and paste this in. Shweeb's saying yes, that's good. Nice, thank you. So let's carry on. So what sort of tools do you use when you're doing this?
So the standard tool chain that we work with, so developer facing, we're still primarily Eclipse.
Okay.
We are probably shying away from that eventually, and that's partly due to making it easy to get everything set up for the build system. So
That
making
makes
it
sense.
so that you can clone and get going, and like it literally everything just works. Um, it might be possible to do that. We have not. So it's easy to say we have not started using checkstyle. That's one thing that everybody has told me we really should be doing, and we even have a draft checkstyle, but we haven't quite gotten there. We have a standard formatting configuration, and that's format on commit as well, or format on save,
Yeah.
which is a really useful thing. We haven't used commit hooks. I did threaten to use commit hooks, but we haven't gotten there yet, just because I felt like it was going to cause more problems to people.
It can be divisive when it comes to
Yeah,
formatting.
yeah. And then, so in terms of CI, we've been using Atlassian Bamboo for pretty much 10 years, but we're moving away from that. So
What
we're
are you moving
migrating
towards?
everything, moving into GitLab.
Oh, okay, makes sense. Yeah.
Yeah, yeah.
Okay.
So Bamboo we actually used because we wanted code coverage for tests.
Okay.
And back 10 years ago, very few CI systems before OpenClover developed worked purely for Java very well. And because we've been using an Atlassian system before. So we're looking at integration between our issue tracker to simplify developer workflow.
Cool.
So we're basically going to throw all this out actually next year and change everything. Mostly because it's old, and secondly because it costs too much.
But you'll still be doing the same sorts of processes in the
Very much
system.
so, yeah, yeah.
So yeah.
So test runners. Probably one of the most obscure things is that because we have a JavaScript transpilation step, which is kind of
Yeah.
like a homegrown, not homegrown tool chain, but it's a tool chain that uses something called Java to script. So we actually have to do browser testing as well as interactive app testing for the transpiled code, because we've got two different versions of
Cool.
runtime platforms. And we actually have to maintain that stuff because it frequently goes wrong with OS updates and browser updates.
Nice. Well, not nice, but you know what I mean. It's useful to
Yeah,
capture.
yeah, yeah, yeah,
It's useful to capture.
yeah,
And it was also it's useful to capture the motivation for change as well.
yeah.
Because that's the why that often, I mean, it's like you were talking about putting an issue or
Mm,
ticket in in your commits. That's about capturing the why behind the change, and
it
those
is, yeah,
whys are invaluable. So
yeah, yeah.
okay, so fair and open, we could spend a really long period of time on, but I'm not. I'm going to suggest we do this very
It can be
briefly.
quite quick, I think.
Yes. So
Code is publicly findable from the Jalview website, which is all public.
yeah,
And the details are we publish the source table as well as the repository being open access. So the license is GPL v3,
cool.
and how can others access the software and its documentation? All via the website, and all archives of the software is also there. Wall formats or standard promotes interoperability. Ooh, it's a notoriously difficult field for interoperability. We
Yeah,
have, um, we have, I, phew, yeah. I mean, this actually is an interesting problem. There are no, there are sort of third-party standards that we could look to, and say, validate us against it. But actually, there aren't that many. In practice, you find that while something says it supports the same standard, it turns
yeah.
out that the nuances of it are not fully interoperable. So we spend a lot of time dealing with quirks. So I guess like a typical standard used to be like the BioPython libraries, which read and write the same formats. But I suppose the common standard formats, MMSIF, PDB, MMSIF superseded PDB for 3D structure. Newick
Yeah.
files are the standard phylogeny interoperability formats. And the various sequence alignment formats, which are FASTA is sort of the commonest one, and GenBank, which is an old school flat file 2-letter tagged format. I'm not quite sure how to describe it any other way. It looks like a Medline record, except it's got biological data in it.
Okay.
Or if you download a reference manager, that's probably the strongest base format, in fact. Might be the oldest. How can others reuse or build? They can download the source and adapt it. It's free software, providing they comply with the GPL. And also they can create services that JalView can access so that they can contribute their own work through. And they can become core committers by joining our discussion list, joining our chat room, saying hello, and telling us what they want to do. And the development process is fully open, so all commits are published.
Cool. I'm going to scoot through just a couple of pieces, the last few sections. I don't think we're going to have time to go through all the sections, but
main entry point is on the website.
Okay.
For the documentation. Are we talking about code documentation though?
It's documentation around the projects. It's not just the code, it's everything around the project as well.
It would definitely be the help section of the JalView website. Yeah.
Okay. So you've got a website, you've got a help section of the website. I presume there's things like documentation in the code as well. You've got readmes, and you mentioned the wiki.
Yeah. So the wiki has actually been deprecated. So
yeah, that makes sense.
I wish it wasn't, but that might come back. What is missing or incomplete? Probably code documentation.
Okay.
We have a lot of document me stubs that were generated when we took over the code from the old when we regenerated the code in 2004 when JalView 2 appeared. And so what do users find most useful right now? I think they find most useful the AlphaFold integration, so that's the EBI services for retrieving data, and that's
the documentation you're talking about.
Oh, right, sorry. Okay, in the
most useful documentation.
So what do users find most useful? They find the hands-on exercises most useful and our interactive videos on YouTube, which
that's really useful.
We pay somebody to so we have a part-time outreach officer who does all of this user-facing training stuff, and that's incredibly important.
Okay.
People don't discover things otherwise.
No. Okay, so let's move on to, we're nearly at the last two sections. We won't do references because I don't, unless you're willing to type into the chat the URL. But sustainability, I mean, we've already talked about who maintains it. It's yourselves, obviously. But how active is the project? You talked a little bit about governance, but if you could expand on that a little bit, and what how is this funded, and so on and so forth.
Yeah. So maintenance. So the primary maintainers are a single research group. So we are embedded within a single research group, and activity we release at least one major version a year and several patch releases for each major version. Governance is semi-formal in that we have this project. We have a traditional research group type PI product owner, but we also have a scientific advisory board, which is also required by our funders. We're funded by the UKRI, so UK Research Council, BBSRC. We're currently actually funded by the Wellcome Trust as well. So our primary funding right now is Wellcome, but in past we've had we've had at least 10 years of funding from BBSRC.
Cool.
And risks or future uncertainties, and I'm not a group leader, so I can't apply for funds. And but what plans exist? So we have a roadmap for minimal cost maintenance of the project and enabling commercial partnership. So our idea is that extensions or customizations may be paid for, and that will help support somebody by somebody's time, or just pay to keep our local CI agents running. Or
okay,
yeah,
cool. I'll leave references for the moment because that's the sort of thing which somebody can add outright at the end. So what I'm going to do is I'll stop. What I'll now do is I'm hoping that you will be able to see that I've got the transcript here. I don't know if it allows you to see the transcript window, or if it shows up as a black blob on your screens.
So it's showing as a sort of a dark blue.
I thought it might show as that. So what I'll do, show in folder.
I forget the name of that shade.
Yeah, and it's closed caption text. So what I now have is I now have this, which is our transcript of the session. I closed the transcript. I don't want to close the transcript. Let's reopen the transcript. Don't actually want to keep that. Right, so where we right, where did we get to? Jim, you mentioned your name's Jim. There we go. I am literally going to cheat. And this is, for me, for my mind, this is what my purpose here is, to show that you can do this thing quite quickly as a good scaffold. So I'll do the save as, and I'll call this as in home, and I'll call it J Proctor. Save. And off screen, I have cheated quite dramatically and uploaded the templates to ChatGPT and asked it to say, I'm going to give you a copy of the template. And I'm going to ask you to fill in the details for me with a transcript. And so this is literally what I'm doing, and literally asking it to do the donkey work of what I would be doing manually. And this doesn't replace doing it manually, obviously. J Proctor. Okay. Because it does replace us having to do all the heavy lifting ourselves. This is the first time I've tried doing this, so you never know. So Jalvi. The nice thing about this is that it gives us a starting point. Is it complete? No. Is it accurate? No, it's not. It's pretty terrible, actually. But it's a starting point for capturing all the different parts in the right places. It's corrected some things as well, because this was written as Emble. It was like you would have it in terms of a summary from a what do you call it? From a system. But the point about this is that I think this is one of the good uses of AI, quite frankly, is to save you having to write all this stuff out yourself. And then if I just go into Google Docs, create a new doc, copy and paste all that out. And what I'm trying to show is that we can use this as a good starting point. It's not perfect, but it means that you'll go away, Jim, with a nice summary of lots of different things that you can share with someone else who wants to onboard. And you can fill out the extra details that you can go with. And this is really what I wanted to show to people, that it doesn't have to be a huge heavyweight task. It can be relatively easy. And if we then do export as mount, say export as mount, download as markdown, and we're done. So that does feel a little bit like cheating, I have to admit. I don't know about other people.
It might be interesting trying with a tool that isn't so extensively documented, because GPT-5 definitely knows about Jalvi. GPT-3 didn't.
Yeah.
It got massive amounts of things wrong with it.
So, but no, the point is that this gives a nice, good starting point. And I think if you do this with a partner or a friend, you can do the same thing. You can have the same questions. I knew nothing about your project beforehand, and now I know lots more about the project. And you can now share this with other people. I'll ask Eleonora to give me your email details, and I'll forward this to you, so you've got a copy. So you'll actually go away with a working skeleton. Other people can do the same thing, and that was what, 40 minutes start to finish. 30 minutes, 35 minutes.
Fantastic. Yeah.
Which is really, really useful use of time. I've had a great conversation. You've had a great conversation, I think, hopefully.
Yeah, thank you very much.
And hopefully other people have found this useful to see how this exercise works going forward. So I'm now going to ask, has anyone got any extra questions?
Well, I actually have a couple of comments, Michael, since we are still in time.
Yep.
But of course, if anybody else in the room wants to add comments, questions, please go ahead, because I know how to reach Michael easily to ask my
Indeed.
question. But I didn't see any hand, so or comment in the chat. So I guess I can indeed go on with my, yeah. So first of all, thank you so much, Michael. I was among the people who were already aware of the process about what research software stories are and why they're important. But I must admit that witnessing the creation, the writing process, made it even more relatable and replicable, easily replicable in so many contexts. And I can think about examples even in my own organization very easily, wherever in fact research software is developed. But so I have two questions. I don't know if you can address both. But first one is, how did you actually came up with all the questions per section? Because there are at least 4 to 6 questions per section that really helped, in this case, our volunteer to explain and also reflect on so many information and details about the software that are interconnected, and how the people behind the research software and the project itself work together or struggle to work together.
How do we get to this stage? Well, it was kind of an iterative process. So a number of the different headings were put together by a colleague called Guido. I forget Guido's surname, and also Shoaib, who's just opened up his camera on as well. Created, I believe, one of the early versions of the template, if not the original version of the template. In that template, the original version says these are the sorts of things which are useful to include in there. And then lots of the questions were written by myself for this particular version of the template. For this session, I just flipped around a lot of the things which are the logical opposites of rather than saying can you list this. It was more a matter of asking you the questions that give you those answers to those. If that makes sense. I don't know if you want to say anything in particular, Shoaib, because you had much more visibility in the very early stages of this.
Yeah, so it started as a call out of information by Katrina Doglioni and Guido, who said I forgot just now as well. Jokland, that's it, Guido Jokland. Requesting from the research clusters the types of some examples of software that they've produced and some of the practices that they use. But this was for presentations. These were recorded. So these were kind of like PowerPoint presentations which were recorded. But then the idea was to move that more into a space where we could talk about the pieces of software and what research practices they used, what research software quality practices they used. But then you still needed all the contextual information. And so we took that and designed that template from the information that they'd requested. And then Michael created some and said, well, actually, this was what was useful. Well, this wasn't what wasn't useful. So we created the actual, and so we iterated so what you see is version 2 or version 3, depending on which way you go about it. And it's kind of taken on a life of its own. And yeah, good stuff.
Good stuff indeed. And in fact, I guess that's the top of the hour. We can say that in fact we are going to organize the next webinar of the EVERSE Network all about the RSQKit. So we might have indeed soon in early 2026 the opportunity to explore the other sections of the kit and the editing process behind that. So I will have the chance to ask other questions, and I hope you have the chance to be with us too. So if you haven't done so, you are very welcome to subscribe to the EVERSE Network mailing list to receive information about upcoming activities and news about us as soon as they are scheduled. I don't know, Michael, if you want to add anything.
No, I just want to say thank you. Just want to say thank you to everyone for attending. Especially thank you to Jim for being willing to play to join in and play a game. It's very interesting to talk to you. Very interesting project, and look forward to sharing the template with you. Well, the story with you that's been created so far.
Thanks very much, Michael. It was a pleasure.
Thank you. Okay, back to you, Ellen.